You know, every single time you hit send on a message, type in a password, or log into your bank, have you ever really thought about what happens next? All that information, your private data, it just zips across this huge open network. It's basically out there for anyone to see.
So, how does it stay secret? I mean, really, think about that. Your private chats, your credit card numbers, it's all flying through the same digital space as everything else. What in the world is stopping someone from just grabbing it out of the air?
Well, the answer is something pretty amazing. It's like an invisible force field that wraps around your data the second you send it. This digital shield is called cryptography, and honestly, it's the unsung hero of our entire digital world. Okay, so what is this invisible shield? How does this digital lock actually work? Let's dive in and see what's really going on behind the scenes. At its heart, cryptography is actually pretty simple. Think of it like a secret code you used as a kid. You take a message that anyone can read, we call that plain text, and you scramble it up using your code. The scrambled message, which is just gibberish to anyone else, is called ciphertext. Only your friend who knows the secret code can unscramble it and get the original message back. That's it. And you see this every single day. You know that little lock icon you see in your browser's address bar, or the S in HTTPS? That's cryptography in action. That S stands for secure, and it's your signal that this invisible shield is up, protecting everything you send to and from that website. Without it, anyone on the same Wi-Fi could just watch everything you do. So how does this scrambling and unscrambling actually happen? Well, it all comes down to something called a key, and there are two main ways these keys work to protect our digital kingdom. Okay, let's break this down. Symmetric encryption is kind of like your house key. You use the exact same key to lock your door and to unlock it. It's super fast, really efficient, perfect for things like securing your home Wi-Fi. Now, asymmetric is different. This is the really clever one. Imagine you have a mailbox with a slot. Anyone can drop a letter in through that public slot, but only you have the private key to open the box and read the mail. This is the magic that lets you send secure information to a website or a person you've never even met before. And this isn't just some abstract theory, you know? This stuff is running silently in the background of your life pretty much constantly. Let's look at a few places you're using it without even realizing it. When you log into your bank's website, how do you know you're really talking to your bank and not some fake site? Well, that's where something called public key infrastructure, or PKI, comes in. It's like a digital passport for websites. It uses that two-key system we just talked about to prove your bank's identity to your browser, making sure your connection is private and that nobody can mess with your transactions. Then you've got your private messages. For this, we use something even more powerful, called end-to-end encryption. This is a total game changer. Think of it like whispering a secret directly into your friend's ear. The message gets scrambled on your phone and only gets unscrambled on their phone. No one in the middle, not your phone company, not the government, not even the people who made the app, can read what you're saying. It is the ultimate shield for private conversation. So these are the actual names of the workhorses doing all this protecting. The big one for symmetric is AES. It's so trusted, it's used by governments, banks, it's even running on your smartphone right now. And for asymmetric, the big names are RSA and ECC. These are the algorithms that handle those digital signatures and the secure exchange of keys that makes the whole modern internet work. But of course, for every lock, there's a lockpicker. It's a tale as old as time. The minute we create a code, somebody else starts trying to break it. And this has led to this constant high-stakes arms race between the code makers and the code breakers. So check this out. For a while, people thought, hey, if encrypting something once is good, encrypting it twice must be twice as good, right? Well, a really clever attack called Meet in the Middle proved that wrong. Instead of trying to guess the two secret keys at once, attackers figured out they could work from both ends towards the middle. They'd encrypt the original message with every possible first key, and then decrypt the final message with every possible second key, and just wait for a match. It was a brilliant shortcut that made this double encryption way, way weaker than anyone expected. But now we're facing a new kind of lockpicker. A threat so powerful it could potentially shatter almost every digital lock we rely on today. I am talking, of course, about quantum computers. And here's the really scary part. This isn't just a future problem. Right now, as we speak, malicious groups are stealing massive amounts of encrypted data. They can't read it yet, but they're stockpiling it. They're just waiting for the day a quantum computer comes online that's powerful enough to crack it all open. This is what's known as harvest now, decrypt later. It's a ticking time bomb for today's secrets. Because of that threat, the race is on. This isn't some far-off sci-fi fantasy. Cryptographers and governments around the world are scrambling to build and standardize new forms of encryption that can resist a quantum attack. And the deadlines are coming up faster than you might think. The good news is there is a solution. It's called post-quantum cryptography, or PQC. This is a whole new family of algorithms being built from the ground up to be tough enough to withstand attacks from not just the computers we have today, but the quantum computers of tomorrow. It's the next evolution of our digital shield. So when you put it all together, what does it all mean? It means cryptography is the guardian of your privacy. It's what gives us the very concept of a private space in the digital world. It's what secures our communication. It's the fundamental technology that lets you talk to a friend, or buy something from a store, or manage your money online with confidence. And honestly, it's not an exaggeration to say that cryptography holds our entire digital world together. Our economy, our social lives, so much of modern society, it all relies on this invisible shield being strong. It's this amazing thing, right? It's completely invisible to most of us, but it's absolutely essential to everything we do. It's always evolving, always adapting to the next threat, and it just makes you wonder, what's the next great secret that it's going to be called on to protect?